first thing that we're going to talk about is interval notation. So example 1, it says, from set builder notation, graph and rewrite the set of numbers using interval notation. So we have 3 examples that are in set builder notation. You need to be able to read these and graph them. You also need to be able to convert to interval notation. So, example A. When I say graph, I mean on a number line. This is how to read this set builder notation. This is read as x. This bar is such that. So this is x such that. This is what's important. That's what we're graphing. That sign is greater than or equal to. So again, this is x such that x is greater than or equal to -2. So if we're at -2, greater than is everything to the right. And we want to include -2, so we are going to have a closed circle. So that is the graph. If you remember, closed circle means include, open circle means you're not including it. Interval notation, so we're going to express the same information in interval notation. You're always going to have 2 values. This is the starting point and the ending point. So if we're looking at our shading, starting point, ending point, we start at -2. And we keep going. There is no ending point, so we say we go from -2 to infinity. Anything that is included, like that -2, is going to get a bracket. Parenthesis, or not parenthesis, infinity is not a number. We can't include infinity. So instead, we do a parenthesis. So you might want to write that. Parenthesis is not included, whereas a bracket is included. But remember, like I said, infinity is not a number. It doesn't make sense to include infinity. So infinity gets that parenthesis. Okay, if we try B, again, this is read as x such that. X such that. This is saying x is between 0 and 3. X is between 0 and 3. If we look at our 2 inequality signs, 0 is not included, so it gets an open circle. 3 is included, so it gets a closed circle. And we're shading everything in between. Okay, for interval notation then. Our shading starts at 0 and it ends at 3. So again, remember, always starting, ending. Start at 0, ends at 3. 0 is not included, so it gets a parenthesis. 3 is included, so it gets a bracket. Okay, and then example C, this is x such that, and here's our inequality. That sign is a less than. So it's read x such that x is less than 2. Less than is everything to the left. 2 is not included, so it gets an open circle. For the interval notation. Okay, here's where we need to be careful. This is where students tend to make the mistake if they're going to make one. That 2 in our shading, is it the starting or the ending point? ending. We are not starting at 2. We're starting down here. We are ending at 2. So 2 actually goes here. It's the second number, not the first one. There is no starting point. We're just continuing to go in the negative direction. So that is negative infinity. Infinity always gets a parenthesis. The 2 is not included, so it also gets a parenthesis. Okay, I would like to emphasize that all 3 of these columns convey the same information but in a different way. So this is exactly the same as this, which is the same as this. They all give the same information but in a different manner. I'm mostly going to want you to use interval notation. So that is the most important. Set builder notation, you're not going to see a whole heck of a lot except in this section, but interval notation is very important. Okay, questions before we look at the next review item? Okay, next review item is order of operations. So if you remember, order of operations is PEMDAS. Either you remember PEMDAS, or you might have been told, please excuse my dear Aunt Sally. Here's what that stands for. So I would suggest you write this down. That first P, or the only P, is parentheses. E is exponents. M is multiplication. D is division. A is addition. And then S is subtraction. So we're going to add on to this a little bit, though, to make it a little clearer. There are really only 4 steps when you're doing order of operations. You will first do all the parentheses first. Then you will do all of the exponents. Multiplication and division are done in the same step. In the same step. So you're not going to do all the multiplication and then all the division. You're going to do all the multiplication and division together. Remember, you're reading left to right. So you'll start left, you'll read. Whatever you get to first, multiplication or division, you'll do. And then you'll keep going. Addition and subtraction works in a similar manner. Those two go together. And then you are going to read left to right. Okay, we're going to do a few examples. Example 2a. It says evaluate when x equals 3, y equals -2, and z equals -1. Okay, so we're going to start by plugging those numbers in. So we get 3 squared, add -1 squared, over 3 add -2. Okay, this tends to be how students write out their evaluating when they plug their numbers in. There's an issue here though. Anytime you're raising something to a power, it's really in your best interest to put it in parentheses. So put those in parentheses, please.
I have a question.
Yeah.
Like, do we really need to put like parentheses around it if we know how to solve it in that? Like, for -1, if we know it's gonna be a positive because it's a negative times a negative, do we really need to put parentheses there, or is that just for work purposes?
In this one, yes. Here, I don't care.
Okay.
But here I do.
Okay.
And it's because if you don't have the parentheses, it has a different meaning.
All right. Thanks.
You're welcome. Okay, step 1. Parentheses. This does not count as parentheses. There's nothing to be simplified inside. But there is an exponent. So if we do our two exponents, 3 squared gives us 9. Negative 1 squared gives us positive 1. Okay, a fraction is the same as division. So we have a fraction here, that means that we're dividing. Before we divide though, in a fraction, everything in the numerator is in parentheses, everything in the denominator is in parentheses. So before we divide, we're going to have to simplify both the numerator and denominator. Numerator 9 add 1 gives us 10. Denominator 3 add negative 2 gives us 1. Dividing, we end up with 10. Your first quiz is going to have order of operations on it. You will not be permitted a calculator. So your first 2 quizzes, you will not be permitted a calculator. After this unit, though, you will be permitted a graphing calculator on everything, as long as you have one. I will not give you a graphing calculator, but if you have one, you can use it. Sound good? Okay, I want us to write another note here based on something that Jaden said. I want us to recall that these two are different. So negative 1 squared versus negative 1 squared, these two are different. This first one is negative 1 times negative 1, which gives us positive 1. This second one is really negative times 1 squared. So in this one, based on order of operations, we do the squaring first, then we apply the negative. So 1 squared is 1, then we apply a negative, and hence negative 1. That's why I said I really suggest that you put parentheses here. Because a lot of times what students do is they don't put parentheses, then they get the wrong answer. And it's because you guys know this, it's just that your notation isn't great. So please know the parentheses matter. Okay. Example B, again we are evaluating. Step 1 is parentheses. We have a lot of parentheses, that's all of this stuff. So we're going to have to simplify all of that before we do anything else. When we simplify that, we have to follow order of operations. So we're going to simplify what I underlined. There's no parentheses in that underlined part, but there is an exponent and another exponent. So we're going to do those.
Did we distribute this 3 before we do the exponent, or no?
Not quite. So this 3 is considered multiplication.
Okay.
Yeah, good question. So we're going to do the negative 2 cubed first. Negative 2 cubed is negative 8. 4 squared is 16. Okay, so that was the exponents. Now we're doing multiplication and division. This is the step where students make mistakes, when it looks like this. We are reading left to right. So we have this multiplication to do. We have this division to do. So we're going to do both. This multiplication, then we're going to do that division. So 3 times negative 8 is negative 24. What I would suggest you do with that negative 16, change it to adding a negative. Change it to adding a negative, because now I know I'm going to be adding. Negative 16 divided by 8 is negative 2. So that becomes negative 26. Please remember, that was just this part. That was just what was in parentheses. So we are not finished. We still have the 7 and the plus 2 out in front. So that was in parentheses. This is what we have now. What are we going to handle first, the 7 or the 2?
2.
2. This is addition, this is multiplication. Multiplication will come first. So 2 times negative 26 is negative 52. And 7 add negative 52 is negative 45. Questions? I would like you to try C. So I want you to try C right now. Start with what's in parentheses. I'm going to give you a minute or two and then we'll come back and go over it. Here's what you should have gotten. So you can see my work down at the bottom, 28x minus 9. Can anybody confirm that you got the same answer I did? Yeah. Okay. I will show you what I did. You didn't necessarily have to follow the exact same steps I did. I distributed that negative 3. Combine like terms. So all that stuff in parentheses should have been negative 7x plus 3. Then what you got to remember is to handle this negative 4 first. Distribute your negative 4, then deal with that plus 3 at the end. Does this seem familiar to us for the most part? Okay. Questions? The last thing we need to talk about is all of the exponent rules. At the top of the notes, you can see all of the various rules that you have learned before. Real quick, if I'm multiplying and I have the same base, I can add the exponents. If I'm raising a power to another power, I'm multiplying them. I can distribute an exponent, but only if there's one term here. So I do want you to write this one down because this is the one that people tend to mess up. What people will do is they'll take a plus b to some power, let's say squared, and they'll distribute that squared and say that it's a squared plus b squared. That is not the case. That is not the case. The difference is, in the rule up here, there's only one term. As soon as you have addition or subtraction, that's 2 terms, this rule doesn't apply anymore. So I want us to be cognizant of that. Okay. So then, quotient of powers should make sense. You've seen this one before. If I'm dividing, I'm going to subtract the exponents. What you have to notice, though, is it's the same base. So it's a to some power again. As soon as they're different bases, it doesn't apply. Anything raised to the 0 power is 1, with the exception of 0. So 0 to the 0 power we don't do. If I'm dividing, again, I can distribute, but that's because this is one term. Again, as soon as there's addition or subtraction, it doesn't apply anymore. Negative exponents move us. Am I talking too quickly? No? Okay, this is the one that is really important, or the one that we are most likely to not remember, and that is rational exponents. Specifically, I want you to pay attention to this second one. On the left, this is called exponential form. Exponential because it has an exponent. The right, this is another way to express the same quantity. This is called radical form. Whatever's in the denominator goes out in front. It's called the index. Whatever's in the numerator stays with the base. I know that's a lot, so we're going to do some examples to hopefully solidify these rules and finish the notes. Example 3, we are simplifying the expressions using rational exponents. So 16 to the 1/2 power. Another way to write that, 16 to the 1/2 is what's on the left side. We're going to put it in radical form. Since 16 is the base, it goes underneath the parentheses. 2 is the denominator, so that becomes the index out in front. And then the 1, there's actually 2 places we can put the 1. We can put the 1 here, or we can handle the 1 at the very end. So the 1 can go with the 16 or it can go outside. I will always follow this way. So this is saying take the second root of 16. The second root of 16 is a square root. So the square root of 16, this part right here, is just 4. Raising it to the first power gives us 4 again. Okay, example B, we're going to approach it in a similar manner. Okay, this -8 is not in parentheses. So really, this is negative times 8 to the 2/3. So we're going to do 8 to the 2/3 first, then deal with the negative. So that 8 goes underneath the radical. What's in the denominator, which in this case is 3, goes out in front. It's the index. And then we are squaring. So again, this 2 can go underneath the root or outside of the root. I keep it outside. Good. Okay, cube root of 8. Some of you can do that in your head, some of you cannot. If you can't, here's how you're going to figure that out. You're going to break down the 8. So 8 is 4 times 2. And 4 is 2 times 2. Cube root means we're looking for 3 of a kind. 3 of a kind. So I have all 3 of these 2's. So that means that the cube root of 8 is 2. So the cube root of 8 is 2, and then I still have to square it. 2 squared gives us 4. But don't forget, we still have that negative out in front. So that's 2. So it's actually a negative 4. Okay. And then C. Again, we're going to switch forms. 81 goes underneath the root. The denominator of 2 goes outside. And then I'm going to deal with that -1. So like I said, the -1 can go under the root, but I want to deal with it later. Second root is just a square root. The square root of 81 is 9. So I get 9 to the negative first, which is not -9. Okay, not -9. The negative exponent, as you can see from above, flips. So this becomes 1/9. Negative exponent will always flip us. So it becomes 1/9, not -9. Questions? Okay, one quick note that I think will help you on your homework, so you might want to write this down. If you have a fraction like this, let's say, -1/2, this negative can go with the 1 or with the 2. So that's the same as -1/2, which is the same as 1/2. So all of those are the same. You would put the negative where it makes more sense. So like in this case, it doesn't make sense to have a -2 out in front, to have a negative index. So we put the negative with the 1 instead. But no, those two are the same. Last 2 examples. Example 4, where we are using the exponent properties. Okay. So here's what we're going to do. First thing that we are going to do is we're going to deal with that 2. So that's an exponent, order of operations. Exponent comes first, so I'm going to deal with the 2. Because there's no addition or subtraction, I can distribute the 2. So this becomes -6 squared. And then I have x to the 4th squared and y squared. Y squared. So I'm just distributing the 2 to all 3 of those. And then that second set of parentheses is just going to stay the way it is. Okay, so then -6 squared gives us 36. Here, power to a power, we're going to multiply. you will multiply. So x to the 4th squared is x to the 8th, because 4 times 2. And then we get y squared. Now this second set, I don't actually need those parentheses. I can get rid of them. Now we're going to combine like terms. 36 times 2 gives me 72. X to the 8th and x to the 3rd. I have 11 x's total. So here, same base. I can add the exponents because there are 11 of them total. For the y, you're going to add the exponents again. 2 add -5 is -3. You cannot leave a negative exponent. That negative exponent will go in the denominator. We get 72 x to the 11th over y to the 3rd. Questions before we look at our last example? Okay, last one. So we have two things to deal with. We have this fraction to simplify, and we have that exponent. We can do either one first, it doesn't matter. So option number 1, we can simplify the fraction. Then deal with that -2. Second option, we can distribute that -2nd power and then simplify. I will tell you my preference is always to simplify first, so that's what I'm going to do. I'm going to simplify what we have in parentheses and deal with that -2nd later. Okay, in this case, with these exponents, division means that we subtract the exponents. So for that x, we have -3 minus -2. And for the y, we have 4 minus 1, because that's like y to the 1st. -3 minus -2, that changes to adding. So I get x to the -1st and y to the 3rd. Then I have that -2nd power. So next thing I'm going to do is deal with that -2nd power. I can distribute it, but remember I can only distribute it because there's one term here. If there was addition or subtraction, I couldn't distribute it. So this becomes x to the 2nd, because I'm multiplying, and y to the -6th. Again, I'm multiplying. So here, we're multiplying. And lastly, that negative power has to go in the denominator. So this becomes x squared over y to the 6th. Questions?